sheet music, the important thing isn't can you read music, it's can you hear it. Can you hear the music, Robert? Yes, I can.
So can you hear the music? Yep. And yep, I'll just simply continue. And yes, today I found out this amazing website called Science Hub where I can just write the name or or a thing called digital object identifier DOI of some scientific paper or any kind of paper, and I will find it. This is amazing. Yep. Now Boot.dev. Scientific papers published on journals, on some website, on some publication like journal like Nature or something, because Nature is paid. Every article is not free there. Yep. And we are on function transform. Yep. I guess I did recursion on my own, like off stream, and the sound is a bit too much. Um, uh, that must have reduced sound for you too. That did not. Okay. Function transformations. Function transformation is just a more concise way to describe a specific type of higher order functions. Higher order functions are functions which take in other functions and can return other functions. A more concise way to describe a specific type of higher order function. It's when a function takes a function or functions as input and it returns a new function. Let's look at an example. This takes in multiply function, add function, and returns square function and double function. Okay, multiply function, add function, and then this self math takes in function, defines an inner function. What does that inner function do? That inner function performs math function, that the function that was passed in on the variable twice, whatever will be passed in to the inner function. Okay, square function takes and multiplies, so and add will double it. Okay, that makes sense. The self math function takes a function that operates on two different parameters. Example, multiply to doc needs a good, and shit, I can just skip it because I won't be able to do the assignment, and yeah, I won't be able to do the assignment, and I understand this thing since I'm coding in C that speaks something. Transformations review. Example of a function transformation. Multiply, add takes in a self function. Okay, applies this operation that was passed in, applies the function that was passed in to a variable that will be passed in on itself. Okay, when does the expression self math add return? It returns a function that doubles the number. Two functions, a function and a function C. And where can inner function be referenced directly inside the function after its definition, inside the self function? Within the add function, only within the self method. Yes, only within the self method. And then more transformations. Here are some example code for you to reference as you work through the assignment. Multiply, add, self math does the same thing as I was doing earlier, and then the assignment, and I can move on. Why transformation? You might be wondering, when would I use function transformations in the real world? It isn't it simpler to just define functions at the top level of the code and call them as needed? Good question. To be clear, we do not just transform functions at runtime for the fun of it. We only use advanced techniques like function transformations when they make our code simpler than it would be otherwise, like wrapper functions or something. Code reusability. Creating variations of the same functions dynamically can make it a lot easier to share common functionality. Take a look at this formatter function. It accepts a pattern and returns a new function that formats the text according to that pattern. That is cool, since it is like, in a way, it is like inheritance in object-oriented programming. Define a formatter. It defines an inner function which takes in a text, and a result is initially 0, I 0, I less than length. If pattern from, okay, we are checking three, okay, we are checking 2 digits, so we did not, yeah, we had to do this. If this equals this, then result plus equal text, result plus equal to text, and I plus 2. Okay, else result plus equal text, and text is the text, otherwise else pattern. Okay, so here I will have two things, and inside whatever the text is, I will get the text. Hello, hello, hello. Yep, do this. Yeah. That makes sense. Closures. 90% of the time when I use function transformation, it is because I want to create a closure. We will talk about closures in the next chapter. Okay. We should use closures are functions which are within functions and can be accessed when the function has returned, when the outer functions has returned, but the inner function has access to a variable that was defined outside the inner function but inside the outer function. That is closure. I heard about closures in No Country for Old Men. We should use function transformations dash when it results in more understandable and extendable code. Yep, first one. Then why transform? Couldn't we just explicitly define bold formatter, italic formatter, and bulletin point formatter as normal functions? Then we would have to define 3 functions, and if we wanted to add any other format, then we would have to define more functions. But with this, we can reuse the code. Nope, this is the only way. Yes, but it will probably require more code. Yep, first one is correct. Filter command, optional, and yeah, that is fine. And filter closures. Yes, this chapter is only closures. Okay, a closure is a function that references variables from outside its own function body. The function definition and its environment are bundled together. That makes sense. The function environment and the function itself, the function definition and its environment. This is the important part. And its environment are bundled together into a single entity. Put simply, a closure is just a function that keeps track of some values from the place where it was defined, no matter where it is executed later on, which keeps which keeps track of the values that were used inside it and defined inside it, no matter where it is called. That makes sense. Where it was defined, which keeps track of some values from the place where it was defined, not executed, where it was defined. That makes sense. Example: the concat function returns a function called doc builder, EA higher order functions, that has a reference to an enclosed doc value. Doc is this, and if doc builder takes in a word, this thing was defined outside, and non-local doc. Okay, inside the function, I define that doc is non-local. That is, it is not global, but it is non-local. It is not inside this function. It is outside this function, and this doc comes from here. Okay, a doc plus word, and add a space, then return doc, and then return the doc function. Now, that would be crazy. This is crazy. This is actually crazy that I can print this thing. Okay, so this function, this thing, lives outside the doc function. Okay. So whenever I'm calling this function, which was returned by this function, it is like this variable has that function, and whenever I'm calling this, the changes that are being made to the doc are stored in a doc that is not local to that function, but to the outer body where that function was called, even though the function in which it was defined has exited. It is still stores, it is still keeps track of what value this variable has, even this function has done its part. That is crazy. When concatenator is called, it creates a new stateful function that remembers the value of the internal doc variable. Each successive call to Harry Potter aggregator appends to the same doc, non-local. But then as a keyword called non-local, it is required to modify a variable from an enclosing scope. Most programming languages doesn't require this keyword, but Python does. This is crazy. Mm-hmm. I think I should spend a bit of more time on this because this is new, and if I do not spend a bit more time, I will forget. I'll forget. Okay. Um, in closures in programming, not like in real life, in having closure with someone. Uh, Enclosures in programming, it is a concept in which a function which is defined in some environment keeps track of of some of the variables that are used inside that function, which were available in the environment, and when that function is called, it still has access to those environment variables, even though the outer function might have the even though the environment might have gone out of scope. It still has access to variables which were defined in that environment, even though that environment might have gone out of scope. But what the crazy part is, what the crazy part, that crazy was like actually crazy. This shit. Yen. What the crazy part part is that on is that the if those variables are updated in the function call, then the subsequent calls to that function will get the updated value. Updated values, not the values with not the values which which those variables held at the time of function definition. That is crazy. It's exactly. Okay, lexical scope is something that I just don't quite get. Why do they use the word lexical scope? I'll have to do some research on what that means. AOCP, um, Art of Computer Programming book. I guess there is a chapter there about lexical things, basic concept, information structures, random numbers, and arithmetic sorting. And okay, sorting and searching have been released. That is beautiful. Then volume 4 is still under construction. Combinational algorithms, combinational searching part 1, combinational searching part 2, and the rest is planned. Recursion is not done. Lexical scanning is not done. Parsing. I would like to see his writing on parsing techniques, the theory of context-free languages, mathematical linguistics, and compiler techniques. I don't think he will be able to finish these. He's very old. He is, I guess, very old. In 2011, he was like this, 14 years ago. He was born in 1938. 1938, he is 10 years older than Noam Chomsky, who is still alive, which is crazy. Robert Roger Penrose is still alive, which is also crazy, unbelievable. And George Soros is also alive, unbelievable. The real kicker is that the enclosed variables aren't just copies of the values at the time of definition. They are not just copies of the values at the time of the definition, they are references to the same memory. That is why updates persist across calls. Like here I have a variable which is defined in the environment in which this function is defined, and then when it is called again, it gets the updated value of the counter variable, which is crazy, actually crazy. Closures, yes. Even though counter has finished executing the result, I have to like write something on my own about this so that I can believe it. Cd python and closure dot pack. Yep, and diff get closure. It takes in nothing, and it has a variable count equals like a string equals empty string, and then a lambda function return lambda. It takes in s, and what is it to? String plus s plus space. This is exactly what was defined there. Now if I get my closure equals get closure function, and then I call my closure on first, and then on second, then third, and then on fourth, and then python 3 closure closure.py. Shit, I do not get anything because I'm not printing anything. Okay, and return this thing. No, don't return this thing. Okay, I do not have to like I have to define a proper function. Closure, this takes in a string s, and string plus equals s plus space, and then at the end, wait, this function, internal function, it returns string, and is I have to also define the non-local thing, and return closure, and non-local string is a non-local thing, and closure. Yep, and then print my closure with value 5th, Python closure and per second interval 5th. That is amazing. That is actually amazing. Due to some reason, I don't even understand the complexities, but that sounds amazing. Let me go to open this enter stack. This is gravity.
It's gravity.
Yes, rust in code. That is too high for you, I suppose. Even for me, that much seems fine. And yep, closures are done. When concatenating, and non-local, okay, yep. And I'm skipping the assignment. I've done assignment on my own. This, yep. Closure, a closure dash the value of a variable outside its body. Outside its body can change. Yes. A function that changes non-local variables. A function that changes yep, is not a pure function because it is having side effects, which is not a property of the pure functions. Assignment and assignment. Yes, I'm going to skip assignment, and that this chapter is completed. I can just go to the next chapter, currying, which I do not know. I heard memoization yesterday, but currying. Function currying is a specific kind of function transformation where we translate a single function that accepts multiple arguments into a multiple functions. Function currying is a specific kind of function transformation. Function transformation is a specific type of high level function, and currying is a specific type of function transformation where we translate a single function that accepts multiple arguments into multiple functions that each accept a single argument, where we are breaking up a function. This is a normal 3-argument function. Yes, this calculates the volume. This is a curried series of functions that does the same thing. Okay, I'm not going to look at what the code is below, but I will try to do this on my own in currying.py. So what I normally have is this box volume 1 comma 2 comma 3. What I want to have is this box volume 1 and then another function and then another function 3. Okay, so the first one is simple, like box volume non currying. It takes in L B height and then return L into B into height. That is just it. But for the currying function, box volume currying, this takes in a single value, right, and then returns a function which returns another function. Wait, no, I do not have to define all the functions all the way. What I can define is a lambda function, maybe lambda, which takes in a value, right, and then which will multiply that, which will return box currying value multiplied by this number. I have to multiply this number. Well, I know that I have to multiply L by X, and do I just return that, or do I return a lambda function which multiplies it? I'm trying to make a recursive approach in some way, but what is the base case? This will never stop. It will keep returning functions on functions on functions. Yep, it will keep returning functions on functions on functions. So, well, I can manually do this. Def, which will take in a value and multiply it by L and return a function which will take in that value and multiply that new value by what I got from the previous multiplication. Mul takes in a value x and return a lambda function, return lambda x, which multiplies x by y, which multiplies y, multiplied by x, multiplied by L, right? And here I have to do non-local L, right, which is this, and then at the end return mul. Now I suppose this 2 into 3 4, this should return something meaningful. Print this thing. Let's see, pi.3 currying.py. This should return 2 into 3 6 into 4 12 24. Stupid retard. And then that does return 24, but I guess that is not the right approach. Yep, here is another example that includes the implementations. Sum a b, return the sum of a and b, right? And the same thing, curried. Okay, take a number, define an inner function which takes in a number, returns the sum. Yes, so this is exactly what I did. I defined it manually, not using recursion. The sum function only takes a single input a. It returns a new function that takes in a single input b. This new function, when called with a value for b, will return the sum of a and b. We will talk about later about why this is useful. Okay, and yes, of course, we are going to skip the assignment. Why cutting? It is fairly obvious. This is simpler than this. Yes. So why would you ever want to do something more complicated, to do the more complicated thing? Well, currying is often useful to change a function's signature to make it conform to a specific shape. Function signature is consists of two functions have the same signature if first they have the same name, second they have the same arguments, and third they return the same kind of thing. Colorizer takes in converter and doc and calls converter on doc here and does some stuff before it, does some stuff after it. The colorizer function accepts the function called converter as input, and at some point during its execution it calls converter with a single argument. That means it expects converter to accept exactly one argument. So if it have a converter function like this, mark down to HTML asterisk style, I cannot pass markdown HTML to colorize because markdown HTML wants two arguments. I cannot markdown to HTML takes in a doc and asterisk style, and I cannot pass markdown HTML to colorize because markdown HTML wants two arguments. To solve this problem, I can carry markdown HTML to a function that takes a single argument. Okay, now at this point, markdown to HTML takes a single argument. Okay, markdown to HTML italic, markdown to HTML italic. Now the asterisk style is italic, and then I can pass down now to colorize markdown to HTML italic, and that makes sense. To match function signatures is when we use currying. To match function signatures is when we use currying. Yeah, okay. And since it is being taught here, so I suppose it is not a bad thing to use it. When passing a function around to be called later, it dash how many arguments the function accepts. It doesn't matter, or it does matter. When passing a function around to be called later, right? It does matter because that changes the function argument, function signature, and that is the only reason that we are using currying. And if it didn't matter, then we would not use currying. So it does matter. Yep, the size matters here. Why currying and then why curry, the same thing here. When should you curry functions in Python? Rarely, only when it serves a clean purpose. Never, always. Yeah, rarely when it only serves a clean purpose. That seems correct. Currying and then assignment, which I will be skipping. Oh, this is a different assignment is there. Yep. Remember, currying is when we take a function that accepts multiple arguments and we convert it into a function that returns a function which takes a singular argument and which might further return another function which takes in a singular argument. Like in here, box volume with length 3, and height 4 and print final volume. Here are the function definitions. Yep, this. Here is always another way where each function is stored in a variable before calling it. Yep. Yeah. And the currying chapter is completed. Should we might be able to complete this today the way that I am going. Decorators, Python decorators, that I do not know. Decorators, yep. I didn't understand decorators when I was learning Python before, like 1 year ago. Well, I was stupid then. But a large part of that stupidity still remains. And yep, everything seems to be working fine. Def vowel counter function are just syntactic sugar for higher order functions. Okay, this function to decorate wrapper functions. Wall counter def wrapper define a wrapper function which takes in a doc and non-local variable called volume count, vowel count, right? Initially vowel count is 0. For char in doc, if char in vowels, vowel increase the vowel count, this thing, and then print the vowel count here and then return to decorator function. Return decorator function with vowel and return the wrapper function. Okay, so that is crazy. Process vowel counter def process printf document. All right, that is actually syntactical sugar. So what this is doing is this and decorator.py. What this is doing is this. I have a decorator function, decorator function, and it takes in non-decor func, and what it does is let's say I will try to make something different than which was given in the example. Let's say that this decorator function takes in functions which return number, and what is something that I can do with a number. I can tell if a number is an Armstrong number or not. Yep, I can tell whether but would I be needing that? Hmm. Present doc. Yep, I'm calling this, and every time that I'm calling this thing, I am getting, yeah, when I'm calling this, I am getting new. Here is one vowel, A, E, I, O, 2, 3. Here is only one. Yep. So the reason that they used this thing is that they used a closure is that they are counting vowels one after another. That is, if in the first document this thing there was one vowel and in the second there were four vowels, in total it will show five vowels and it will keep track of the vowels. That is why it has defined this vowel counter outside the wrapper function so that it keeps track of what the latest value was after updating it. The vowel counter line is decorating the process doc function with the vowel counter function. Yep. So what I understand is this: I have a function which takes in a function and it it defines a function which stores in a variable the number of vowels that are in the provided string and that then prints those vowels and then continues to call this function on the text that it got, right? And then it returns this wrapper function. And after doing this, writing this thing here, whenever I call whenever I'm calling this, no, not whenever I'm calling this function is equivalent to this name process doc is equivalent to vowel counter being given the input as input this function, and whenever I'm calling process doc it is equivalent to me calling vowel counter over this function and then giving the document to that inner function which is returned by the vowel counter function. I guess that makes sense. It does not make sense completely to me because it will take time to let a bit sink in, but yeah, it makes some conceptual logical sense. The vowel counter line is decorating the process doc function with the vowel counter function. Yep, this line is decorating this function with this function, and vowel counter is called once when process doc is defined with at the rate syntax, but the wrapper function that it returns is called every time. That But the wrapper function that it returns is called every time process doc is called. That is why vowel count is preserved and printed each time. Now I have a question. Where is closure.py? Yep. Inside closure.py I defined one closure, but if I say other closure and get closure and change the last two to other closures, and also print other closure with sixth. Let's see, I predict that I will see 1, 2nd, 5th printed first and then 3rd, 4th and 6th. Python closure error command from Python 3 closure.py first, 2nd, 5th and then 3rd, 4th, 6th. Because these two functions are different and differently called with different environments, and from each environment it is getting the initial declared value of a string which was defined in the upper function. That makes sense. And wait a minute, I will be right back. And yep, I am right back, as you can see. It is just syntactical sugar. Yep, makes sense. Python decorators are just another, sometimes simpler way of writing a higher order function. Simpler way of writing a higher order function. These two pieces of code are identical. I can either define it like this, right? This function like this, vowel counter, or I can do, yes, vowel counter, process, call vowel counter with process. Yep, that makes sense. Process dot, yep, that makes sense. And then, yep, we can just move on to the next lesson. Args and quarks. In Python, args and quarks allow a function to accept and deal with a variable with a variable number of arguments. Args, why is there a star? Args collects positional arguments into a tuple. Okay, and quarks collects keywords named arguments into a dictionary. Positional arguments into a tuple and keyword arguments into a dictionary. Keyword arguments. Okay, okay, that is also the way that we can define arguments for a function. These go inside KW args, that is keyword arguments, and args get these arguments as a tuple. Positional arguments are those you are already familiar with, where the order of the arguments matters. Looks like this. Yep, a minus b. I will be subtracting the first thing from the second thing here, -1. Quarks are passed in by name. Order does not matter, like this. B equals 3, I will be subtracting b from 3. Yep, for this I yep, b is 2, and yep, for this I will have to know the parameter names, not names of the argument but names of the parameters with which that function was defined, and I can say explicitly that b equals 3 and a equals 2. A note on ordering: any positional arguments must come before keyword arguments. This will not work. Yes, because what position does this 2 get? That makes sense. And yes, as stupidly, I will just skip the argument. What did I learn? I learned about arguments. How can I take multiple arguments, and how can I take keyword arguments, quarks, keyword arguments in a dictionary. Makes sense. And I do it in the function definition by using a star before args and 2 stars before keyword arguments. Now next, decorators, which is this. Yep. Okay, decorators. The args and star arg syntax is great for decorators that are intended to work on functions with different signatures. Yes, functions with different signatures, because those decorator functions can write as arguments to those inner functions these args and kw arguments. That makes sense, because then the decorator function does not has to specifically know what the what that function which was provided to it as its input takes as arguments. Like right here, function to decorate can take in any arguments. That makes sense. Counter is this wrapper takes anything and non-local list count one increase this many times. Yep, and then call that function with the same arguments. The log call count function below doesn't care about the number or type of the decorated functions. Number or the type of decorated functions. Function to decorate arguments. Functions arguments. It just wants to count how many times the function is called. However, it still needs to pass any arguments through to the wrapper function. So it can just say ambiguously that this is what it takes, and the same thing goes into the inner function. That makes sense. And again, stupidly, I will skip the assignment. Decorator review. A Python decorator is just syntactic sugar for higher order functions. Syntactic sugar just means a more convenient syntax. A more convenient syntax. Yep, a more convenient syntax. Not all programming languages have built-in decorators, but most do support high order functions and closures. Some of the most famous functional languages are Haskell, Erlang, Clojure, Lisp. I have heard Lisp, I have heard Haskell, but I have not heard Erlang or Clojure. Do have some special syntax decorators, but they do have higher order functions and closures, meaning the decorator pattern can still be used. So if you understand these concepts, they will serve you well into many different languages. Okay, functional decorators are not as often supported as plain higher order functions. Yep, yes, they are not functional decorators. Decorators themselves are not supported as often as higher order functions, first class functions are. And decorator view function currying means changing the syntax, changing the signature of a function so that it adheres to what we want its signature to be. A function currying higher order functions, function currying higher order functions, function transformation on a function to change its functional argument, functional signature so that it adheres to what we want it to be. Function currying higher order functions and first class functions are unique to purely functional languages, unique to Python, unique to object. No, that is wrong. Commonplace is known in most programming languages. Well, it is commonplace in languages which support higher order functions. Unique to purely functional languages. Purely function. No, Python is not purely functional. It is also object oriented. It is not unique to Python. It is not unique to object-oriented commonplace in most programming languages because most programming languages support functional programming support. So that is what I'm going with. And the rest is optional, which I'm shamelessly going to skip. And I can just go to the last type, which is some types, which only has 5 chapters, 5 lessons. Sometimes. Remember when I said pure functions, and I think I won't be able to retain much of it because I am spending very little time, but I understand function transformations. It means passing in a function to a higher order function and doing something specific to that function. Closures. Closures are closure is a concept in which a function is able to reference to some variable which was available in the environment in which that function was defined, and even though that environment has gone out of context, that function is able to refer to that variable. And if that function is called again and again and the function makes some changes to that variable, it will get the updated latest value, not the original one with which it was defined. And currying means changing Occurring is a type of functional function transformation in which a function's signature is changed accordingly as we need it to be changed. Some types. Remember when I said pure functions are my favorite part of functional programming because they do not have any side effects and they are have one-to-one mapping, so which is cool. Well, some types are a close second. Okay, a sum type is the opposite of a product type. Okay, this Python object is an example of a product type. Man dot student finance is true. Man dot has trust fund is false. Okay, the total number of combinations a man can have is 4. The product of the two. That makes sense. If you were to add, yep, that is because it has two values and binarily I can only have 0 to 3. If we add a third attribute, then it has 8 possible things. 1, 2, 3, 4, 5, 6, 7, 8. Yep. But let's pretend that we live in a world. We live in a beautiful world. Nope, we don't. We might. Let's pretend. Let's pretend that we live in a world where there are really only 3 types of people. Only 2 types. Only 1 0 type of people exist. Um, First who understand binary and the second who don't. But let's pretend that we live in a world where there are really only 3 types of people that our program cares about. Dateable, undateable, maybe dateable. Okay. Yes, so the total possibilities that this can have is 3. It can either be this, or be this. Yep. We can reduce the number of cases in our code needs to handle by using a arithmetically fake polyphonic sum type with only 3 possible types. Class person in it self takes in a name. Okay, it gives that to the name to that, and we can reduce the number of class cases our code needs to handle by using a admittedly fake Pythonic, my bad, Pythonic sum type with only 3 value types. Okay, dateable, maybe dateable, and dateable. These are 3 different class implementations which take in a person. So these are, and this is inheritance, right? And then we can use the in is instance builder and function to check if a person is an instance of the subclasses. Okay, if a person is an instance of dateable, maybe dateable, undateable subclasses, it is a simple way to represent sometimes, but hey, it's Python. Def respond to text guy at bar. If his instance of at guy at bar dateable, then return this guy at bar dot name. I'd love to go out with you. Else, if it is maybe dateable, I am busy, but let's hang out sometime. Have you tried being rich? Shit. And then invalid person type. Sometimes as opposed to product types which can have many often infinite combinations sometimes have a fixed number of possible values. To be clear, Python doesn't really support. Sometimes we have to use a workaround and invent our own little system and enforce it ourselves. We have to create our own little system. Why do I need some types? Maybe in this case, when it either is something or it either is not something. Then enum, yes, enums, yep. That is where I need it. And the battery is low, so I will continue fast.
Enums are one of the best things to happen to programming,
Yep.
and that's including the release of the best operating system of all time, Windows Vista. But before we talk about enums, let's brush up on a little bit of category theory. And despite the word theory being added to scare non-academics, it's really not too bad. In programming, types are how we categorize things. For example, this partner class contains two variables, both of which are Boolean types. So the partner type actually contains other types. And this is common when working with collection types like lists, tuples, and classes. The interesting thing about this partner class is that it really has four possible combinations of values. Studies finance can be true, has trust fund also true. Studies finance true, has trust fund false. Studies finance false, has trust fund true. Studies finance false, has trust fund false. And that seems manageable, but what happens if we add a third field? Well, if it's also a Boolean, then the number of possibilities actually jumps up to 8, because we have to multiply
Double.
4 by the available combinations again, which is 2, getting 8 possible total combinations. If we add another, we get 16, and if we go up to 5, then we get a total
32.
number of 32 combinations. And if we add a string into the mix instead of a Boolean, then the number of total possible values essentially goes up to infinity, because a string can contain any number of combinations of characters. Now, this is where the term product type and sum type come into play. They're also sometimes referred to as algebraic data types, just to scare the non-PhDs. The partner class is a product type because the total number of possible combinations of values is the product of the number of fields, right? 2 times 2 times 2 times 2 times 2, however many Boolean fields we had in there.
52.
But product types are very interesting. Almost everything is a product type by default. Lists, tuples, and classes with, a number of properties. And the problem is that product types result in many possibilities. And even primitive types like strings and integers have the same problem. When you have a string type, you don't know if that string value contains the entire text of the novel Moby Dick, or the string hello world, or the empty string. There's so many possible combinations that could be stored in that
Makes
type.
sense.
And that makes them hard to work with. Right? When you write a function that accepts one of those types as a parameter, you have endless if-else statements and switch cases and fallbacks to handle all of the different possibilities that could arise when your function is called with different values. That's where sum types come into play. They're just types where the number of possibilities is limited to a finite set. A Boolean is a good example of a sum type. It has two possibilities, true and false. When you're working with a Boolean, all you have to think about is whether this variable is true or false. Okay, so now we can finally talk about enums. Enums are another sum type, like a Boolean, and really I like to think about them as kind of extended Booleans. For example, let's say we want to write a button class, and in this button class we want to specify that it can be one of 3 colors. We could have the buttons constructor accept just a string to define which color it's going to be, and we'd accept either the string red, the string green, or the string blue. Now, the problem is that our button class now needs to take into account that whoever's creating a new button could pass in any string, right? They could pass in the string teal, or they could just pass in a misspelled blue, and we need to handle both of those cases. The better option is to use an enum. And at least in Python, the way you can define an enum is using the enum package. You pass in the name of the enum, in our case, we'll use color, and then the possible values that are valid in this new type. So in our case, red, green, and blue. Now in our code, if we use color.red, it will work. It will resolve to the color red. And as far as the color type is concerned,
Color dot red. BTN, not color. This contains enum. Okay, this color can have only 3 values, and this color does not have 3 values. It has enum called colors, which has 3 values, and I can from this refer to all 3 values.
everything will work smoothly. But if we try to use a color that was not specified when we created the color type, like teal, the Python interpreter itself will actually throw an error. So now the language itself will raise an exception if we ever try to use the wrong value. And that means that in all of our code, we no longer need to have all of these if-else statements checking and making sure that the variable maps to a valid value, right? There might be 10 different places in code that have to check the value, and we don't want to rewrite all that code. In a language like Python, the interpreter will yell at us when we run the code if we ever use an invalid value in an enum type. But in statically typed languages, like a lot of the compiled languages like Go or TypeScript or C, we'd actually get the errors either at compile time or even better, right in our editor telling us that those values are not allowed for that type. That said, enums are still useful even in a language like Python. Python's not statically typed, so it does mean we'll have to actually run the code to see the type errors, but at least the valid values, red, green, and blue, are defined when we create the enum type. So there's a single place to reference so we as developers can see what colors are valid types, and we won't have to keep redefining it every time we check the value.
Okay, enums. Yep. Move on. Sometimes, unfortunately, Python does not support some types as well as some other statically typed languages. Python does not reference your types before your code runs. That is why we need this line here to raise an exception. If it is any of these, then do this. Otherwise, raise an exception. In a language like Rust, we can write something like this. Color takes in a color enum and returns a string. Match color. Okay, like and that is Rust. Notice how there isn't any case for unknown values. That is because the Rust code will fail to compile. Step that happens before the code runs at all. If the color is a different value, this static enforcement is a huge benefit of some types, and it is a shame we can't get that in Python. Which language does not support proper sometimes Rust? Oh, Python, my bad, Python. That is the same code, okay? Why are sometimes useful? Because you know that you only have a limited set of expected values that a variable can have. Right. That is low battery and only one lesson is remaining. You have to run your code to see if you have handled all possible cases. You can know before your code runs that you are handled all possible cases. They ensure that your variables can hold any type of value. Second one seems right. You have to run your code to see if you have handled all possible cases. You know before you run your code that you have handled all possible cases. Yes, because all possible cases are already predefined. The last thing. Shit, which is this is the final lesson. Okay, there are required lessons that are not yet complete because I do not have the premium subscription. Let's take another look at enums example. Okay, this. Yes, I have not worked with enums. I have not defined them. I will have to tinker with them, or I will like go deep into them. Not deep, but I will understand them later when I actually use them. For now, it is good enough that I know that there is something called enums. Python has a match statement that tends to be a lot cleaner than a series of if-else statements. That is like switch in C. Okay, match this with case this with case this. If this is this, then do this. Else, in case like default case, do this. If you have two values to match, you can use a tuple. I can match two values at once, which is cool. And the value we want to compare is set after the match keyword, which is then compared against the different cases patterns. If a match is found, the code is then discovered. The code is then in the block is executed. This. That makes sense. Match enum. Okay, now we have done that. Learning functional programming. Now we can move on to this. Build a static site generator. That will be cool, but not today. Well, not like on stream right now. And right now I will be ending stream. My laptop is on low battery. My phone is on low battery. Yep, that is it for today. Yeah, it has been 1 hour. I didn't thought I would go as far as 1 hour. Okay.